Hello again. This is Statistics 220 at Hudson Valley. Today we're going to discuss Chapter 7, which is Continuous Probability Distribution. Two things you should print out for this lecture. And this is probably the most important lecture to view the video versus the PowerPoint presentation, because I draw a lot of curves and it's very difficult to see that on my PowerPoint presentations. But prior to this video, you need to have printed out a Chapter 7 video. Let's go to the doc cam. Okay, this is Chapter 7, and you should have 2 pages of it, 1 through 13, because we're pretty much, this video is going to do all of them. The other thing that's essential you print out is the Z table, which is in Blackboard under reference material. There are actually 4 tables, but in Chapter 7 we will only discuss this Z table. So please print those out. You might want to put it on pause. Okay. So we're talking about continuous distribution. Let's go back. We're talking about continuous distribution versus a distribution, a binomial distribution that we discussed in previous chapter. Binomial distribution was like the number of flights, airline flights that are late to an airport. We could have exactly 1 or exactly 2 or 0 that are late. In this chapter, we're doing continuous data. Continuous data, we will do a normal distribution. Okay. Our center point will be our population average. Let's say we're measuring the number of grams of cereal in a box of cereal, and it could be 250 with a standard deviation of 10. Okay. This is our data. Because there are infinite number of combinations of mean and standard deviation, we will convert that combination into a z-score, because we could have had 240 grams of cereal and a standard deviation of 5. Or we could be measuring seconds or money or time. Okay? So we convert all of our continuous data to a z-score. Our mean will always have a z-score of 0. The area, total area under the curve will be 1.0, total area. So therefore, half the area, or this area I'm shading, will be 0.50, or 50. The area under the curve corresponds to the probability. So I could say the probability of selecting a box of cereal that weighed 250 grams or less is 50%. On the other hand, the probability of grabbing a box of cereal that weighs 250 grams or more is also 50%. So you need to keep those 2 concepts in your head. The area under the curve is 1, half the curve is 0.5, and we're converting all our data to z-scores, where the mean starts at 0. These are negative z-scores, and these are positive. Okay. So we have those concepts. Let's go to our handout and look at our very first problem. First problem, it says, what percent or proportion of the factory workers can assemble the parts between 75 and 81 seconds? There's several steps. Our first step would be to write the givens every time. I think I'm going to ask you to do that on every single problem for the rest of the semester. So our population standard deviation is 75 seconds. Our standard deviation is 6. And our x variable in this example is 81. That's our first step. Second step, draw your normal distribution. Again, I said the average will be in the center. Standard deviation is 6. And x is 81. If this is 75, then 81 is right here. And if you read the question, it says between 75 and 81. So we want to shade this area. Now we want to convert these both to z's. Well, we know the mean is 0, but what is that? Well, we use the formula z x minus the population mean over standard deviation. In this example, 81 minus 75 over 6. And on purpose, it came out to exactly 1. This is your z. Now we go to our z table. So pull out your z table, and remember our z is 1.0. If you notice, these are our z's and these are our z's. These 4-digit numbers here in the center, all of these 4-digit numbers are percents. You might want to write over here that they're percents, just to remind you, the 4-digit numbers are percents. Okay, well 1.0, how do we look up 1.0? We looked up the whole number 1, the first decimal point here in the left axis, but the second decimal point, we would look along this axis. In this case, it happens to be 0. So we look at 1.00, and our percent is 0.3413. I'll give you a second to find that, 0.3413 on your z table. So this is how I denote it, and you'll see a green arrow on my PowerPoint. So it's 0.3413. That is the percent between 81 and 75, or right here, 0.3413. Or we could say 34.13% of our employees can assemble the part between 75 and 81 seconds. We can also ask a question a different way and get the exact same results. I could say, what is the probability going out in my factory, selecting one individual, and they assemble the part between 75 and 81 seconds? That probability is 34.13%. So that's number 1. Let's go to number 2. Again, the givens. What percent of the factory workers can assemble a part between 69 and 81? Well, again, given the mu is 75, standard deviation is 6, this time I have an x of 81 and I have an x of 69. When I have two x's, you are going to have to calculate two z's. But our next step is to draw the curve. Here is our center point. Here is our standard deviation. And I say 69. 69 is to the left, and 81 is to the right. I have to calculate the z for both of those. Okay, z, 81 minus 75 over 6, which we've done before, which is 1. Our z is 1. We looked that up in the table, and we got 3413. Okay, again, one important step I did not do. We're looking for 69 to 81. So we shade this area and this area. So this area, as we did from the previous problem, is still 3413. If we calculate z for 69 to 75 over 6, lo and behold, we get a negative 1.00. We don't have to worry about the negative right now, and we get the same exact percent. So this percent is 3413. Okay? We always, when we use the z-table, we have to start from the center and go out. We can't go directly from 69 to 81. We have to calculate this area and this area. To find out between 69 and 81, what do you think we do with these two probabilities? I bet you're right. We add them. 0.3413 plus 3413, and we get 0.6826, or about 68.26% of our employees can assemble parts between 69 and 81. Remember, you can't go 69 to 81 directly. You have to calculate 75 to 81 and 75 to 69. If I give you two x's, you have to calculate two z's. Remember that one. Okay? So let's go on to example 3. Example 3. What percent of the factory workers can assemble the parts between 63 and 81? Given. The average is 75. Standard deviation is 6. I will always give you this. Again, I give you two x's, 63 and 81 again. Second step, draw the curve. You'll notice I make lots of room for the curve and the calculation. That little space I give you on the handout will not be sufficient. So 63 is here. 81 is here. I want to know this area and that area. Because I have two x's, I have to calculate two z's. Well, for the third time, this is 1.0. We look up that z in the table, and we get 3413. So we know that, 3413. Now this area, a little different, 63 to 75 over 6 equals a negative 2.00. We look that up in the table, and we get, let's look at that up, 2.0. 2.0. Let's look 2.0. 2.00.4772. 0.4772. Again, that's that area. 0.4772. What do we do with these two probabilities? We add them up, and we get 0.8185 is the total probability between 63 and 81. And that was number 3. Okay? Number 4. Number 4, what percent, this is again from your handout, what percent of the factory workers assemble the parts over 61 seconds? Given. Mu is 75. Standard deviation is 6. And I said x is over 61. Draw the curve. 75, 0. 61 is to the left. Here's 61. And I said over 61. I'm going to ask you, do we shade A, B, or C? The answer is B and C, because I said over 61, and everything to the right of 61 is over 61. So let's first, I gave you 1x, so we're going to solve for z. 61 minus 75 over 6, okay, is 2.33. There's my z. Look up 2.33 in your z table now. What'd you get? I hope 4.4901. So that's this area. However, I said anything over 61. So what's the probability of getting 75 or over? If you remember from a few minutes ago, half the curve is 0.5. So I add 0.49 plus 0.5, add it. So this total area that is 61 or greater is 0.9901. The chance of me selecting somebody from my factory and that person being able to assemble the part in greater than 61 seconds is 99% chance. So just about all my employees can do that. Great. Okay. Move on to 5. What percent of the factory workers assemble the part in exactly 61 seconds? Exactly 61. Given mu equals 75. Standard deviation of 6. X is exactly 61. Whoops, my curves are getting... Here's 61. Think about this. I didn't say, what am I going to shade? I didn't say below 61. I didn't say above 61. I said exactly. What's the area of a line? 0. You can't do exact numbers. Because if I measure the time you take to assemble a part and you say, oh, it's 61 seconds, well, I can find a measuring device and it might be 6101. Or I could find another measuring device that says 6101.5. So you cannot do exact numbers. Can't be done. You can do it on binomial. I can tell you exactly one flight will be late, but you can't do it on continuous data. This was a trick question. I like trick questions. That's a hint. Let's go to number 6. Number 6. What percent of the factory workers assemble the parts in less than 58 seconds? Okay, given. This is not a trick question. X. And I said less than 58. So let's draw the curve. 75, there's my Z. Less than 58. Would I shade A, B, or C? Less than 58, right here. Okay, so I gave you one Z, so let's calculate it. Z, 58 minus 75 over 6 is negative 2.83. This is a Z. If I look it up in the table, or you look it up on the table, which you should be doing as I discuss this, you will find a percent of 4977. Now that 0.4977, that's the area or the percent on the curve between 58 and 75. It's right here. This is 4977. This area right here. That's not my answer. My answer's here. Well, I know half the curve is what? By this time you should be screaming out 0.50. Well, if half the curve is 50, this area is 0.4977. To find that area, I subtract 0.50 minus 4977, and I get 0.0023. 0.0023. So this is your answer. I'll give you a minute to think about that. When we calculated the Z and found the percent, that percent is always between these two numbers, between 58 and 75. So draw it right on your curve. And you say, ooh, that's not what I'm looking for. I'm looking there. How do I find it? Well, I know half the curve is 0.5. I subtract 0.5 from that, and I got my answer. Number 7. What percent of the factory workers assemble the parts in more than 83 seconds? Given mu is 75, standard deviation is 6, x is 83. Here's 75, here's 83, and I say more than 83. Do I shade A, B, or C? And yes, I can hear you. You're screaming right here, C. Good job. So let's calculate my Z. 83 is always minus the population, 75, divided by standard deviation. And I get 1.33 is my Z. Let's look that up in the table. 1.33. 1.3, and then here's 3. And I come down, I get 0.4082. I'm not sure if you can see that, but you sure can hear me. 0.4082. 0.4082. Well, where is that percent? It's between 83 and 75. 0.4082. That's not what I'm looking for that. Again, we know this half of the curve is 0.5. We know this is 0.4082. To find that, we just subtract. Okay, so this is 0.0918 is our answer. So little over 9% of my employees, it takes over 83 seconds for them to assemble parts. You might make a business decision and say, you know what, 9% is too much. Let's retrain those 9% so they can be below 83 seconds to assemble the part. Okay, let's look at question 8. What percent of the factory workers can assemble the parts between 59 and 66? Ooh. This is probably one of the hardest ones. Given that 75 is your mean, standard deviation is 6, and I gave you 59 and 66. By the way, on a test, I am going to give you a different mean of 75 and a different standard deviation of 6. I might give you a box of cereal that weighs 300 grams, or I might give you a tire that wears in 32,000 miles with a standard deviation of 1,000 miles, or I might give you an average salary of $11.50 with a standard deviation of 25. I'm not going to stick to this. I'm only doing this for demonstration purposes. Okay, so I gave you 2 x's. Next step, we draw the curve. 75, where the population is always in the center. X is 59. The other x is 66. They're both on the left side. Now, let's read the question again. What percent of the factory workers can assemble the parts between 59 and 66? Between 59 and 66. So should I shade A, B, C, or D? Well, right now you're getting good at it, and you say B, right in here. That's got to be my answer, between 59 and 66. Okay. Well, I gave you 2 x's. That means you have to calculate 2 z's because we start from the center line out. So Z, 59 minus 75 divided by 6 is negative 2.67. Negative 2.67. The other z is 66 minus 75 over 6. And that gives me a negative 1.5. And I'm going to stick these z's right here. Okay, by the way, before I look them up in the table, this means I am 2.67 standard deviations away from the mean. It means 66 is 1.5 standard deviations away from the mean in the negative direction. These are negative because we're on the left side of the curve. So if we look both of these up, I'm going to give you a chance. Look them both up. 2.67. By the way, round that up. 2.67 is 4.4962. 1.5, 4332. Okay, well, what are they describing? This is describing between 59 and 75. It's describing from here to here. This area is 0.4962. What's this percent describing? Between 66 and 75. Between 66 and 75. It's describing this area. So this is 0.4332. Neither one of those is my answer. I have this whole, I have the part. So how do I find that area? I subtract those two. When you subtract those two, 0.4962 minus 4332, you get 0.0630. So this area is 0.0630. This is my answer. Okay? Going to go on to number 9. Don't forget, you're welcome to pause this anytime if I'm going too quickly. I'm trying to get all this done in a short amount of time, and you can go back and spend time on it. Number 9, what percent of the factory workers can assemble the parts between 80 and 85? Well, you know what? I am going to let you do number 9 all by yourself, because number 9 is exactly like this problem, except on the right side of the curve. Okay? And you can review your answer on my PowerPoint presentation. So, that's for homework. Let's go on to number 10. Now, in my PowerPoint presentations, I'm not sure if I have a 10A, but let me quickly explain. Up until this point, let's go back to, let's say this one. I gave you the population, the standard deviation, and I gave you 1 or 2 X's, and you found the percent. The next couple examples, I'm going to give you the percent, and we're going to find X. For example, if I said to you, 10A, 50% of my workers can assemble the part in how many seconds? 50% of my workers can assemble the part in how many seconds? Well, if we go along here, this line, right here is 50%. So 50% of my workers can assemble the part in 75 seconds. I found the X. It happens to also be the population mean in that example. So let's go on to 11, which is a little more challenging. No, sorry, 10. How many seconds go by before 15% of the factory workers have assembled the part? Well, first thing you do is write your given. Mu is 75. Standard deviation is 6. And this time, I don't give you X. I give you the percent, which is 15%. Same exact procedure. We draw a curve. Here's 0. Here's 75. 15%. So I'm coming along here, and right here is 15%. And I said, well, how many seconds go by? I'm looking for my X. I don't know. But I gave you this percent. If you remember, I said the Z table, you always have to go from the center out. We always find this percent. So if this is 15%, what's that percent? If you can't figure it out, let me give you a hint. Remember I said this is 50%. If this is 50%, this is 15%, we can calculate that by 50% minus 15%, or 35% is there. So we have that percent here. Now, let's look at our Z formula. Z, X, mu over standard deviation. What do we have? Well, we're looking for X, so I'm just going to put it as X. We know our population of 75. We know our standard deviation of 6. Z, we have to find Z. Well, I know the percent is 0.35. So you take out your Z table. We know the percent is 0.35. We find 0.35 or a number close to 0.35 in the center of these percents. So if I come along here, here's 0.3485. That's about 15 away. 0.3508, that's 8 away. 0.3531, that's 31 away. So 0.3508 is the closest percent, and we'll select that. Well, how do we find the Z? Well, we come out, and our Z is 1.04. Let's do that again. We found that 0.3508 is our closest percent. We've got to find our Z. We come out on our Z table to 1.04. So our Z is 1.04. However, it's on the left side, so it has to be minus. This has to be minus. That's very important in this equation. So now we can solve. I'm going to do a little bit of algebra to remind you. We're looking for X. We multiply both sides of the equation by 6. These cancel out. We're left with X minus 75 on the right side. We're left with, we multiply those and we get minus 6.24 on the left side. This is minus 75, so we're going to add 75, add 75. They can't, 75. They cancel out. I have X. And if we add those up, we have 68.76 is our X. Our X is 68.76. Now, I don't know if I've said it before, but this is a good spot. Does the answer make sense? Here we have 75. We know our X is going to be a little bit less. And yes, 68.76 is a little bit less. It makes sense. So let's review. I said I have 15% here. So therefore, to find 35%, I said 0.5 minus 0.15 and got 35%. I looked up 35% and found 0.3508 in the table. That corresponded to a Z of 1.04, so I put it into the equation. It had to be negative because it's on the left side. I'm looking for X. I put my population, 75, standard deviation, I solved, and I got an X of 68.76. This is a little difficult concept. I cannot deny that. Okay, so let's do 11. 11. Given mu is 75, x, oopsie daisy, standard deviation is 6. And I say how many seconds go by before 60% of the factory workers have assembled the parts. So I give you the percent of 60%, and I'm looking for x. We draw a curve. Here's our mean, 75. Let's think about when I said about 50%. I'm coming along here, and I'm looking for 60%. I'm coming along, here's 50%, and well, let's say right about here is 60%. Okay, I'm looking for this x that corresponds to there. Well, I have to find the percent from here to here. What is that percent? Think about it. I came along here. This is 50%. This is 60%. This is 10%. So I look up 10% in the table to find, this is the percent, I'm looking up the closest z. What's the closest z to 10%? Well, the closest is 0.0987. When I look at that, it's 0.25. Let's look at that. 10%. 10%. The closest one here is, this is 13 away from 10%, 0.0987. This is over 50 away, and this one's 26, so it's right here, 0.0987. I come out to find the z. It's 0.25. 0.25 is your z. Okay, let's stick it in the equation. 0.25, this is my z, 0.25. Is it positive or negative? It's on the right side. It's positive. Positive 0.25 equals, we're looking for x, 75 over 6. Once again, we do a little bit of algebra. You can handle this. Come and see me if you forget your algebra. Negative 1.50, right? Check me, I've known to make a mistake. If I solve for x, add 75, add 75. Up, this is positive. See, I do make mistakes. This is positive because it's on the right side. I add it, and I get 76.56. This x is 76.56. That makes sense. Slightly more than 75. Sorry about that. That should be a positive. That should be a positive. Okay? Let me do number 12. 12. How many seconds go by before 2.5% of the factory workers have not assembled a part? Ooh, given. Okay, given. Mu equals 75. Standard deviation is 6. I'm looking for X, and I gave you a percent of 2.5. Okay? Let's look at the curve. And this is a little tricky. I said how many seconds go by before 2.5 have not. So is your 2.5 here or 2.5 here? It's 2.5 is right there. Because this is the percent that have not. So therefore, I have to subtract it from 0.5. Have 0.475. I get a Z of 1.96. I'm looking for X. So Z is a positive 1.96 equals X minus 75 over 6. And when you do the algebra, it's 86.76. 86.76. So my X. 13. This is a little different one. We've been finding 1x. Well, I will give you a question like this. Within what symmetrical limits around the population mean will 95% of the assembly times fall in? Okay, you write your given. Mu is 75. Standard deviation is 6. I am looking, when I say symmetrical, whoops, you can't see it. When I say symmetrical limits, I'm asking for 2 x's. And I give you 95%. So let's look at this. What am I talking about? When I say symmetrical limits, here's 75. I'm saying I want to know these 2 x's. And 95% of my assembly workers will fall in those limits. Well, once again, from the center out. The center out. Well, how do we find this percent? If the whole thing, and it's symmetrical, is 95, 95 divided by 2. 95 divided by 2 is 0.475. 0.475. Okay? If we look that in, we get a positive 1.96, and here's a negative 1.96. Since I'm looking for 2 x's, we have to calculate two of them. So we have a Z 1.96 equals X, we're going to call this X1 and this X1, minus 75 over 6. And we have a positive 1.96 equals, we'll call this X2, minus 75 over 6. We do the algebra, and X1 is 63.24, and X2 is 86.76. So exactly 63.24 and 86.76. 63 seconds to 86, 87 seconds. 95% of my employees can assemble parts. This should look familiar because the empirical rule is approximation to that. Remember, if you go to your formula sheet, I say 95%. What's the formula for 95% in the empirical rule? It's the mean plus or minus 2 standard deviations. Well, if I use the empirical rule for this, I say 75 plus 2 standard deviations and 75 minus 2 standard deviations. And what do I get? I get 87 and 63. Close, very close. The empirical rule is an approximation. When I do it this way, it's an exact value. I want you to think about that for a couple of minutes. Now the last problem I'm going to do. We have been talking about continuous data. However, if we have binomial data, like plane flights, but we have a lot of data, we can use, let me go back so you can see me. When we have binomial data, like the number of flights, or the number of students late to class, or the number of cars entering the parking lot, okay? And we have massive amounts of data. We can use the continuous formulas to approximate the binomial. So in this example, we're going to do that, okay, with the pizza example, my favorite subject, pizza. Normal approximation to the binomial. Santonio's Pizza Restaurant found that 70% of its new customers returned for a meal. For a week within 80 new first-time customers dine at Santoni's, what's the probability that 60 or more will return for another meal? Well, if you remember our formula, which I'm sure you do, to calculate Z, when we have this formula, every one of these has to be recalculated. Let's start with mu. Well, let's start with the givens. 70% return. We have 80 new customers, and we want to know 60 or more will return. Okay. When it's a binomial like this, first step, we're going to draw the curve. Well, we have to calculate mu. So mu, and if you look on your formula sheet, is n times the probability. Remember, in this book, probability is pi or p. So we have 80 times 70%, which is 56. So our mean is 56. Okay, so we have our mean. Now we have to find our standard deviation. We have to calculate standard deviation. Standard deviation, square root of n times probability, 1 minus probability. N, 80 times 70% times 1 minus 70%. And when you do that calculation, you should get 16.8. So our standard deviation is 16.8. Okay. Now, let's look at our formula. Z, X. We're going to get to X in a minute. We found our mean. Oops. Square root of that. Again, excuse me. Square root of that, I believe, is 4.10. Check me on that. My notes are a little sloppy here. So I'm going to use this. 0.410 is our standard deviation. X, I said 60 or more. Well, here's 50 or 56. 60 or more, 60 or more. So I'm shading that area. Well, because it's a binomial, and this is a little trick that only I teach my students to determine how to calculate X. X will be plus 0.5 or, oops, lost you again. X, we have to add 0.5 or subtract 0.5. We have to add or subtract 0.5 or subtract 0.5. How do we know? Well, let's look at, I tell students to draw the curve. and put an exaggerated box around the x value. Well, we have to include that entire bar because it's a binomial. Well, you notice right here, this area is not included. So therefore, instead of using an x of 60, in this case, we have to bring it back to 59.5. And that's what we put in to the formula, 59.5. And when we calculate that, we get a z of 0.85. We look it up in the table, and we get 0.3023. Well, where is that probability again? Remember, it's between 59.5 and 56. It's right here, 0.3023. That's not what we want. We want the tail. So we have to say 0.5 minus 0.3023, and we get a probability of 19.77. This is the example that I have on my PowerPoint presentation, so that will help you. Okay? So in this case, the x value we had to subtract. I'll quickly show you and end this presentation when we would add. If I gave you a problem and I said, okay, let's go back to my my problem with pizza. My pizza example, so my mean was 56. My standard deviation was 4.10. And I said to you, what is the chance of, let's say, 60 or less? 60 or less. So here's 60. And I said less, so I would shade this area and this area. So I have a z 56 over 4.0. Because I had to calculate this. Now the x, I have to add 0.5 or subtract 0.5. Well, I exaggerate my bar, and this time the right side of the bar is empty. So instead of using 60, I had to add 0.5 or 60.5 to get my z value. Okay? So this pretty much concludes what I wanted to do in Chapter 7. Let me go back to the instruction. This is a lot to absorb. Okay? This was on population data. The purpose of this chapter, and I'll test you on this chapter on the shading, because that's very important for the rest of the semester. We do it here on population data in Chapter 7. In Chapter 8, 9, and typically in statistics, we sample data. So we're going to do the exact same concept of shading. However, we're going to use a slightly different formula. Okay? And after Chapter 7, we will only use sampling data because that's what you do in statistics. So thank you again. I know this video was a little long. I hope I didn't put you to sleep. I usually do put the students to sleep on this video. But I think it's very important that you saw how to shade. Again, if you have any questions, you can email me. You can stop by my office hours. You can try to catch me on my phone at work. That's the most difficult way to connect with me. But I'd love to sit down with you and help you out. So have a good day and take care.